Hi students, this experiment is your mode 10 counter. Okay, you have studied this counter. This is also known as decade counter. This is capable of counting the number of clock pulses equivalent to decimal line. So this is also called a BCD mode 10 counter. Okay, binary coded decimal. So you can observe the truth table for BCD counter. 4 outputs are taken there: Q0, Q1, Q2, Q3 from flip flop 0, 1, 2 and 3. Okay, 4 flip flops are used. In this case, we have used JK flip flop. And when you observe this truth table, at serial number 8, the Q1 and Q2 are 1. Okay, you can observe this Q1 and Q2 are 1, which make AND gate true, and J input of the FF3 is 1. Okay, we have used AND gate between Q2 and Q3. Okay, your F2 and F3, FF2 and FF3. Okay, your third flip flop and last flip flop. We have you can check it from this circuitry. You can clearly see before the clock to FF3 is fed through a AND gate. Okay, which is made high according to your Q1 and Q2. Okay, if Q1 and Q2 are high, then clock will be set for FF3. Okay, FF7 is to 0. The Q1 and Q2 are also 0, when which disable the AND gate, and J input of F3 is 0. Okay, which pull Q3 at 0 on next clock cycle. Okay, so your serial number 9. Okay, your count number 8 and 9. Okay, these are made possible by this AND gate operation, which we have purposely introduced between FF2 and FF3. Okay, for these when the inputs to this AND gate is 0 0 from FF1 and FF2, clock is 0. Okay, and when the input is 1 from FF1, output Q1 and Q2, then the clock is set. So this is the circuit which we have to implement in Proteus. You can clearly observe the circuit from the circuit that we have used 4 JK flip flops. Okay, input is given at J, which is common for all the flip flops through logic state I have used. So you can make this connection according to this circuit diagram. I will share this separately to your group. So this is IC number 7473 for JK flip flop, and for monitoring the output I have used BCD to 7 segment decoder IC, that is 7448, and 7 segment display common cathode is used for monitoring the counter operation, okay, decade counter. And logic probes are used at output of your FF naught. You can check it with your question. This is shows your with your question mark sign. Okay, this is your, this one you can see, this is your logic probe at the with the sign of question mark. So you can check the output 0 or 1 on this. And this is your IC number 7448, used for BCD to 7 segment decoder. And this is your 7 segment display common cathode. Okay, and you need to ground this pin. And here you can see reset signal is given through a circuit. Okay, from where with this circuit comes, you have gone through a previous video which I have shared with you. In that you have seen a reset logic expression. Okay, that what that expression says, y equal to, we derived it from Karnoff mapping. In that video you can check it. Y at that time was y equal to d bar plus b bars dot c bar, right? That was your reset logic for this mode 10 counter. If we introduce this circuit for reset switch, reset operation, only then after counting from 0 to 9 it will reset. Okay, this is your reset logic. So we have to introduce it between your reset input, okay, between our reset input. So you can clearly see output taken from OR circuit or gate is fed to the reset switch. Okay, reset input. So this is made reset. You can call it clear also. Okay, reset or clear, this is the same thing. So once the count approaches to 9, after that it reset the logic and count begin from 0 again. So this is your complete BCD mode 10 counter circuit. So I will share a small video of simulation. You can check and understand the operation. Clock is fed with your clock inputs. Okay, this is your clock. So just observe this circuit, and simulation part I am sharing with another video. Thank you.